Okay, now I'm going to start explaining on the derivation for this A and N. So in this example, we have three layers, which is input layer, hidden layer, and output layer. So this one is the input data, these are the neuron, and this one is the final output. This one W14 is from neuron 1 to 4, W24 is from neuron 2 to 4. So it will be the same for all the line here. So for the forward pass is like this. So for the hidden layer, we have 4 neurons. So we have 1, 2, 3, 4. So for the next 4 here, neuron 4 will be the weight time with the input. So we have 3 inputs here. So we plus 3 input together to get the net 4. Then after that is the O4 is the output from this net 4. So it's the output here. So the output will be the function of this net 4. So for the upper layer is a net 8. This one neuron 8. So because we have 4 line, so this will be the weight time with the output from this neuron. So all the outputs here. So then we plus together, then we get net 8. Output from neuron 4, 5, 6, and 7. So the final output, which is the y head, is the function of the net 8. So this one, the final one, is a function of this net 8. So that's all for the forward pass. So for the backward pass, will be delta W48. So this one is the change rule. The change rule is not that long because only involved from here until here. Okay, so because backward pass, so we have a delta there. So the del y head is sorry. This one del net 8 over del W48 is O4 is from here. We differentiate del net 8 correspond to the W48, so we get the O4. Then all this will become 0. Then differentiate del y head correspond to the net 8, so we got this one apostrophe F apostrophe, which is the differentiation. So del E over del y head is this formula, the error from the output. So these two will be cancelled, and then differentiate this one, the coefficient is -1, so we bring in front here. That's why we got the formula of this one. So to simplify, so this one will be replaced with a notation of E8. Okay, this one is times all these 3 together, so we get this one. So these two can be simplified with one more new notation, which is the del 8. So this one is E8, so here is E8 times the F apostrophe net 8. So this one is the overall formula. So we just times all together, alpha times this del 8 times O4 from here. So for the upper layer, we have 4 lines, so we have to do for 4 times 1, 2, 3, 4 from the output from the neuron 4, 5, 6, and 7. So the backward pass for the hidden layer will be longer because it involves until hidden layer, which is from here back to here. So the change rule will be longer. So the DO4 over del net 4 is this one. So we differentiate del O4 correspond to net 4. So we get the differential of the net 4. This one. So this one del net 4 over del W14 is this one. This one. So we differentiate net 4 correspond to W14. So we only get the S1, and these two will become 0 because we only just differentiate corresponds to this one. So these 3 will be the same with the previous one, which is this one. And del 4, so we can simplify these 4 together to become del 4. So this one is a del 8, which is previously we calculate this one, del 8. So del 8 times W48, this one, times this one. So we get this one. And then for the E4, because is del 8 times W4 8, the E4 is here, the del 8 is here. So to get the E4, we just times del 8 times with the W4 8, so we can get the E4. So it's more simplified. So we get this equation. This will be replaced with the E4 from here. So the overall the formula is this one. So the alpha, and then this 4 will replace with the delta 4. This one is delta 4, and then this one is the x1. So we got this. So in the hidden layer, we have 4 neurons from the 3 input. So we need to do 1, 2, 3, 1, 2, 3. Then for the neuron 4, 5, 6, and 7. So for the general step, so we'll change the number of the neuron. So in the like the first column here will be 1, 2. If here got one more neuron, will be neuron 2, 3, 4, something like that. So will be add if your neuron is more. So inside the bracket is the number of layers. So this one is layer 2, this one is layer 3. W11 is from 1 to 1, W12 is from 1 to 2. So it will same for all the line. So for the forward pass in the hidden layer, so we look at the net 1 layer 2, which is this one, net 1 layer 2. So since have 3 inputs here, so it will be W11 layer 2 times with the output from this neuron, O1 layer 1. So the 3 together will be plus together, so we get the net 1. Then the output from this one is here, so will be the function of the net 1. So you can see here. So it will be the same for 1, 2, 3, and 4. This one 1, 2, 3, 4. So for the output layer, which is the net 1 layer 3 here. So we have 4 lines here. So 4 input. So this one weight will be times with the output from this neuron or this neuron. Then we plus together, we'll get the net 1, 3. So we plus 1, 2, 3, 4 together. Then this one is the final output, the y head. So it's the function of the f net net 1 layer 3. This one is a final. So it will be the function of this one. So finally we get the final output. So for the output layer, for the backward pass, because we are going back, so we are going use delta again. So we start from the layer 3. So this one is the same with the previous one, just replace with this layer, number of layer, 3, 3. This one is the output from layer 2, which is the from here. Because we are in layer 2, so it's output from layer 2 times with this one. Then times with alpha, so we get this one. So we have 4 lines, so 1, 2, 3, 4. So backward pass for hidden layer. Also same with previous, just we replace the notation, this one, layer 2, layer 2, layer 2, layer 1, because this one is from the output from layer 1. We back from here, we back to here. So here is the output from this layer 1. So we time with this one. So be the same for the all the neuron. So to summarize all the backward pass and the forward pass for output and hidden layer will be here. So for the output layer, so the very first one we use this one. This one y here minus y because minus inside, so this one become plus, this one become minus. So when we change to the second one, the more general one, so will be this one, the E8, which is the output layer, so we put number 3. And because we have 1 neuron, so we put E1, so minus y equal to y head minus y. Then we'll put in a metric form. So if I have these two outputs here, E1 and E2, so in metric will be E1, E2, and y head 1, y head 2, y1, y2. Then all these matrix can be put in a vector form, which is like this. Then for the del, this one is output layer. So output layer is layer 3. And this one is the first neuron for the output layer. So this one also the same. All the output layer become 3. Then we put in a metric form. Then because this one is times, so in a vector form, this one will become the Hadamard product because it's a times with the element wise. So for the hidden layer, because we have 4 neurons in the hidden layer, so you can see all replaced with the number 2, which represent a hidden layer. So we have 4 neurons, 1, 2, 3, 4 in a hidden layer. And then this one is from the output layer, the number 3, layer number 3, because we only have one output layer, so it's all delta 1. So times with the weight from the second layer. Then we put inside a metric form. So from here we can see like 1, 2, 3, 4. So in a metric form will be like this. Then you go to this one times this one. Like because it's like 1, 2, 3, 4. So we can put in a more generalized form, which is in the vector form. So we get this one. Because this one is don't have times here, so this one is a dot product for this hidden layer. Then for the delta in the hidden layer, so it's the same. The first one because we have 4, 5, 6, 7, then we replace with the layer 2 because the hidden layer is layer 2. Then for the neuron 1, 2, 3, 4 in layer 2. So this one also same. Then we put in a metric form. Then after that we put in a vector form because got many here to represent this metric. So here also had my product because here is a times here. So for the general step in algorithm form will be, for the first step, initialize the weights. We initialize the W and the B, and then set number of layers. So in this example, the number of layer is 3. I'm go to 3. Then enter the input from training data to obtain the neural network output. So this one will be our input data. Then we will get this y head. So after we get this y head, we'll compare with this y to get the error. So which is step number 3 to calculate the local error and delta. So this one is this one. For the output layer. This one. Then after that, step 4, propagate the output neuron data backward. Then calculate the delta of hidden layer, which is this one. This one for the hidden layer. So we'll put this one and this one. So as you can see here, this one. Then for the k equal to n minus 1, because our layer is 3, so 3 minus 1 is 2. 2 to 2, so this will run for once only because 2 to 2. But if our layer is 4, 4 minus 1 is 3. 3 to 2, so it will run for 3 and then run for 2 times. So now we move to step 5. Adjust the weight according to the learning rule. So this one is the gradient listen algorithm. So we update the weight for every data. So from L to 2 to M. Then after that, this one is step 6, repeat step 2 to 5 for every training data point. So example, if we have 50 training data, so step 2 to 5 will repeat for 50 times to update this new iteration, the parameter for the new iteration. So for 50 times. Then after we repeat 2 to 5 for 50 times, so we get a 1 approach, which is this one, repeat step to 6. So this one is the first iteration for the first training data set. Then if this one, let's say, is 50. So if we repeat for 50 times for this step, so we get 1 epoch. So we repeat the epoch So we'll get a graph like this. So this one first approach, second approach. So we can set the approach to stop at which number. So we'll get the minimum point at this graph here. Okay, so that's all from me. Thank you.